In this session, we are going to be looking at balancing redox reactions, and specifically acidic solutions. What I'm going to do is I'm going to go through a few examples, as you can see here, and just hit you with a bit of theory. Hopefully by the end of it you should be more confident with balancing redox reactions. So the first thing is, in a redox equation, or a half equation, or a full equation, we are allowed to add three different species to balance out. The first one, which you're familiar with, is the addition of electrons on either side to balance. And the other two are water molecules and H plus ions. And the rationale behind that these are usually found in the aqueous solution, which usually is what allows your redox reaction to occur. So let's go ahead and look at the first example. Here we have chromium ions and Fe2+, which form Cr3+, Fe3+. First thing you need to do is put in the oxidation states. So oxygen is -2. There are 7 of them, making -14. The overall charge of the ion is 2-, which makes the chromium +12, because +12 minus 14 makes 2-. As there are 2 chromium atoms in this ionic molecule, that means overall the oxidation state is +6. Compare that to chromium on the other side, which is +3. From left to right, what we have actually done in this reaction is we have reduced the chromium. And we know that because each chromium gains 3 electrons. Next, Fe2+ remains as a +2 oxidation state, and Fe3+ is a +3 oxidation state. Again, in the reaction, we can see that it's been oxidized, where each Fe loses an electron. So the next step, which you should be familiar with, is forming the half equations. So to start the half equation off here, what we are going to do is we're going to take the Cr2O7 2-. I'm going to leave a bit of a gap in case I need to add anything, and I'm going to write down what it forms. The most obvious change I can do is I can double up the Cr3+ on the right hand side to balance out the ions on the left, the chromium. But there's another conundrum here. We have an O7, and there's nothing on the right hand side to balance it out. So this is where the water molecules come in. We can add in H2O, and that provides the oxygen to balance out. If you notice, there are 7 oxygen atoms on the left, so we need 7 water molecules. But there's still another issue here. And the second issue is, or the new problem we have, is the hydrogens. There are 14 hydrogen atoms on the right. So the other species we can add is H+, of which we need 14. Now, as a half equations should always show electrons. And in this case, as it's a reduction reaction, that means we are adding electrons. 3 electrons per chromium, which give us 6 electrons altogether. That is the first half equation complete. The second half equation is slightly easier. We have Fe2+. Again, I'm going to leave a gap, and then Fe3+. And it's quite clear in this reaction that we're becoming more positive, and if the ion is becoming more positive, that means we have, or the ion has actually lost a single electron. Fe3+ plus an electron will form Fe2+, and vice versa, where it removes an electron. Great, so we've got the half equations. The next job is to combine these to form the ionic equation. Now, when we combine these, we need to cancel out the electrons. 6 electrons in the first half equation, there is only 1 in the second. So we can multiply the entire second equation by 6. And that brings us up to speed here. And then go ahead and just combine the two. So if we combine the two, we end up with Cr2O72 minus plus 14H plus 6Fe2 plus 6 electrons. That forms 2Cr3 plus 7H2O plus 6Fe3 plus and 6 electrons. And it's a simple case of cancelling out. There are no H pluses on the right, there's only water. We can cancel out the 6 electrons, and that leaves us with our final equation, which is the exact same equation minus the electrons. And that there is our final ionic equation. And you've shown now the combination of two half equations. Right. I hope that was useful. What I'd like you to do is have a look at the second equation and the third and have a go yourself at doing this. In the next video that I will post, I will share the solutions for both of these, in fact all three of these reactions.